Oh. Oh. Can anybody hear me? There's no feedback here. So why?
Okay, so good morning, everyone. Welcome to our course, ACS-1904. Hopefully, you are doing all right. So, day by day, actually, is my sound is okay, or the slide I'm sharing, is that okay? Can you hear it? Like, see the slide and hear my sound? Perfect.
Yes, I can hear you now.
Okay, and you can see the slide?
Yes.
Okay, yeah, that's perfect. So, you know that the current situation is not very good. So I will request everyone again to maintain the social distance and no social gathering. So you know that suddenly for Canada, the number of cases is like suddenly increased, right? So even in Winnipeg, in one day, they found 14 cases. If you look at Quebec, like it's like 1,500 cases. Okay. So in Canada, it's kind of now around 4,000 cases. And in Europe, like the condition is very bad. So if you look like the whole world, total number of deaths is around 22,000. So we need to be very careful, and hopefully it will be okay soon, but we never know when it will be end. I know it's very tough, you know, like doing all the things inside your home rather than going outside. it's boring also. So you have to be mentally prepared for this actually. There is no other way we have in current situation. Anyway, so let's start today's class. We know that so assignment 3 was due yesterday night. So hopefully like you already submitted. As so far I saw like 22 submissions. That is also okay. It will be more. So lab. So to this week will be last lab. Any question? Okay. So this week will be last lab. So I will post your assignment number 4 very soon. Hopefully tomorrow. Also lab 10 will be posted tonight. And what else we have? So before starting, do you have any question regarding our previous topic called recursion? Any questions so far understanding recursion? So again, we will start by playing the Kahoot game. Okay. So I will request everyone to join. So you know how to join. Go to kahoot.it and give the pin 889424. So there should be like 8 participants or 8 players. Are you guys having trouble joining in? Okay, here we go. Six. What is coronavirus today? Seven. I'm just putting one more player. Anyway, we can start. Hopefully he or she will join soon. So the very first true or false question. In general, we have two kind of recursion. Is true or false? For sure it's true, right? So what are those two kind of recursion actually? One is we already know, that is recursive method, right? Another is recursive data structure, right? The winner is Shelby. And the next question is, in recursive method, there should be what, where the recursive function will terminate. See if you can remember, we went for several examples in our last class. For sure it's base case, okay? Not extended case, not worst case, not all of the above. The winner is again Shelby. No, it's Go, the programming language Go, maybe. The next question is, to control the execution of methods, the Java virtual machine uses a memory structure called the what? So look at each of the option and then click. Yeah, so those who just click stack, Actually, the term is named as call stack. Okay. So if you look at the examples, also in the examples, we are saying call stack rather than stack. So I know that you already know, like, it's kind of a stack, but the name actually is call stack. Okay, here. So the winner is AI. Okay. So the next question and the very last question. If an association involves the same class more than once, we say the association is it linear, quadratic, recursive, or none of the above? For sure, it's recursive. Congratulations to all of you. Like, you all click the right answer. So the winner is the second runner-up is the Go programming language. First runner-up is AI, and the winner is Thomas. Okay. Okay, so we can go back to our today's lecture. Okay, so in last lecture I told you that rather than starting a new one, maybe we can go for examples, but for recursion it's kind of you know that we'll practice recursion in our lab 10 also. So rather than that, if we got time in the next week, we can go for some example. I thought like it would be better if we start the next topic, okay? Because the next week is our last week, and also we have to do the review of the final, and maybe I will go for a review also for the assignment number 4 if I get time. So maybe we can just start the next topic, and then if we got enough time, maybe we can go for some examples to practice, okay? But you have the lab to practice there as well. So let's start. So today's topic, shorting and searching. So these two terms is already known to you for sure, right? So what is shorting? We are putting the list into sequence, right? So normally what we do, it's actually ascending order of shorting. Okay, we can do descending order, but whenever we will go for the examples for shorting, we will go for ascending order. Okay, what about the searching? There is a list, we need to search whether a particular element is there or not, right? So there are many kind of shorting, but the common thing is that in all of the shorting, you will see that a common practice is followed. What is that thing? Okay, so if you have a list of m elements, if you look here, we are kind of dividing the total list into two lists, right? One is the sorted sublist, and that is the unsorted sublist. So whenever we look for the example, all the time for all of the sorting, we will have these two lists. One will be sorted, another will be unsorted. And the main concept is the sorted sublist will be expanded or extended, and you know that the unsorted one will be shrinking, like for each iteration. Okay, so that's why we are saying many algorithms conceptually consider a list that comprises a sorted sublist and an unsorted sublist. Clear? So what kind of thing we do for sorting a list? Maybe we just swap. So what we're doing here, we are just swapping with third with the sixth element, right? Okay, so suppose if our numbers are 3, 6, 55, 66, 67, 22, we know that if we just do a swap between this 22 and 55, our data got sorted, right? So swap is one option. What else we do for sorting? We do shifting. So what is shifting? We just do like one by one, we are checking and we are doing the things. So suppose you know that this 22 is very end of the list, right? So here we are not swapping, rather than what we are doing here is 22 less than 67 years, is 22 less than 66 years, is 22 less than 55 years, right? If 22 less than 6, no, we will stop here, we'll put this 22 in this position, okay, and just this guy, we'll just shift right, just like that. Is it clear? So any questions so far? Okay, so we're going to learn 4 sorting algorithms today. First one is selection sort, then the insertion sort, then the bubble sort, the very last is quick sort. But there are many other sorting algorithms available. Okay, so in this course we're not interested on those, because those are more related to, these are also data structure kind of, because we are having a particular data structure for sorting, but also we have merge sort, we have heap sort, we have bucket sort, we have radius sort. Okay, and those will be covered in your data structure course, that is ACS-1904-002. Okay, you have the data structure and algorithm course, I think. So those will be covered in that course. So let's start with the selection sort. Like I said before, for every sorting we're kind of follow two lists. One will be sorted and there will be unsorted. Okay, so here the idea is this sorted list will grow larger and the unsorted one will be shrinking. Okay, and another idea is that we'll find the smallest one and move it to the beginning of the unsorted list. Okay, so let us go for the algorithm of like how this sorting like works. Okay, so you know that at the very first of our iteration we have the sorted sublist totally empty, right? Nothing is sorted, right? And then we have the unsorted sublist, actually whatever the list you are list you are going to sort. Okay, so you have two lists, and then we have a iteration. So in each iteration, what we're going to do, find the smallest entry, we call it maybe X, in the unsorted sublist. Okay, swap X or interchange X and the first entry of the unsorted sublist. Okay, so in each iteration in the unsorted sublist, we are looking for which one is the smallest, right? And then we'll just interchange with the that smallest entry with the very first entry of the unsorted list. Okay, so whenever we do that, that first element in the sorted list, like on the left side, it will be increment by 1, and you know that the unsorted list will be decrement by 1. So let me give you one example here. So suppose at the very beginning we have the numbers 30, 40, 50, 10 and 20. Okay, so in the sorted list we have nothing at first. In the unsorted list we have these 5 numbers, right? So our algorithm says number 3a, find the smallest entry, right? So here what is the smallest entry? We have 10, right? So like I said before, it will be interchanged with the first entry, right, of the unsorted. So unsorted, so you know that the first entry is 30, right? So that's why there is a interchange with 10 and 30. So 10 goes at first and 30 goes to the place where 10 was. Okay, that's the idea. So this is after the very first iteration. Okay, so in each iteration what we're doing, find the smallest of the unsorted and solve the first of the unsorted. Clear? Okay, so now this is in the sorted list, this 10. Okay, so whatever the red line, it's just separating the sorted list with the unsorted list. Okay, So now these are our numbers 40, 50, 30, 20. Which one is the smallest? 20, and it will be interchanged with the first element of the unsorted list with 40. Okay, so 20 goes here and 40 goes there. Clear? So at the end of the second iteration, we have 10 and 20 in the sorted list, and now we have 50, 30, 40 in the unsorted list. Again, find the smallest of the unsorted list, that is 30, right? And interchange with the first element of the unsorted list. Okay, so 50 goes here, 30 goes here. So we have now 10, 20, 30 in the sorted list and 50 and 40 in the unsorted list. Now at the very last iteration, we have only two numbers. Find the smallest, that is 40, and just replace with the first element of the unsorted list. So if you interchange, we are done. Okay, so we have now 10, 20, 30, 40, 50. So is this example clear to everyone? Do you have any question regarding this selection chart? Like, do you clearly understand how it works? Okay, so what I will do now, so if you just Google like sorting visualization, you will find a nice website. Okay, so this is the website I'm talking about. It's called visualgo.net. Okay, so here there are some sorting things. You will get these things later. So all the things you can visualize. So these are things related to computer science. Okay, all the things like graph structure, binary search tree, linked list, hash table, binary heap. You will see one by one. So for today's topic, we can go for sorting, and it will visualize how things are working. Okay. So suppose you can choose here which one we'll go for. So for ours, we need just selection sort, insertion sort, then we have quick sort, we have bubble sort. Okay. So then what you can do here, you have option here, what kind of sorting you are going to do. Okay, like whatever you choose here, you will see here. You can also see kind of the algorithm in this panel. Then you can create your own number. You can like type whatever the numbers you want to play with. Otherwise, you can just choose random to make the numbers randomly coming. Okay, and then you can click short, you can click go. Before that, if you have like if you want to decrease the speed of like the iteration, you can slow it down. Okay, then if you just click go, okay, you can also pause during the like the visualization. Okay, so it will just say what are the things doing. Okay, so it also instruct you what are the things is doing in the current iteration. Okay, clear? And then it will go for the algorithm. So we have 3 right now, right? And then you know that it will just go find out what is the smallest, right? So 3 is the very first element of the unsorted list, right? So it got 2, so that's the smallest one, right? So it's a swap like what we just saw in the slide. So now our number is 44. Then it will check one by one what is the smallest. You can increase the speed if you want. You can go back even, like this is the slider. Okay, maybe I can just increase the speed a little bit. Yes, so find the smallest one and just swap. Okay, so this is the way all the numbers will be shorted. Okay, clear? So you can use this visualization website. I can also just I'm just in the chat box, I'm just giving you the link. Clear? Okay, let's go back to the slide. Okay, so any question? Okay, so now we'll start insertion sort. Okay, so what about the insertion sort? Initially, first element is part of the sorted sublist. Okay, whenever we'll start the very first element, it will be part of the short sublist. Then the idea is move first of the unsorted into proper position of the sorted elements. May require some shifting. Okay, so let's go for the algorithm, like how it works. It will be more clear then. So at the very first, in the sorted sublist, like I said, the first element of the list it will be, and the unsorted sublist, you know that the remaining n minus 1 elements if you have total n elements in the list. Okay, so how the iteration works? So for sure repeat until the unsorted sublist is empty. That's our target. Okay, so let x be the first element in the unsorted list. Shift entries that are greater than x to the right, making the room. Okay, for x in its proper position in the sorted sublist. Okay, so what we're doing here, whenever we have this x and then we have some numbers, right? So we'll see like which one is greater than x. If anyone is greater than x, we'll make it right shift. Okay, and then we'll position that x in a proper position. Then x will be the part of the sorted sublist and the unsorted sublist will be shrinking by 1. So let's go for the same example. We have the numbers 30, 40, 50, 10, and 20. Like I said, in this sorting, the first element will be the part of the sorted sublist and rest of the numbers will be part of the unsorted sublist. So that's why this red line bar is pointing here. Okay. So now what we will do, we'll take the next number. Okay, we'll check the sorted sublist. Okay, whether it's less than the number or not. So you can see that this 40 is not less than 30, right? So we will not do anything. Clear? Okay. So that's why we are saying in each iteration, move the first unsorted element to its proper position in the sorted sublist. So it's kind of different than the previous one. We're not finding the smallest one, rather than we're going one number by like one number, one by one, the numbers one by one sequentially. And whenever we are having the shortest list, and okay, we are checking the very first number of the unsorted list inside the sorted list and make a proper position there. Okay, so we know that there is no shifting things necessary because 40 is not less than 30, so we just keep it like this. Again, we come here in the 50 number 50, right? So we know that this is not less than 40, right? Okay, so we just put it whatever it here. Okay, then the next number is 10, right? We'll go for the perfect position for 10. Is 10 less than 50? Yes. Is 10 less than 40? Yes. Is 10 less than 30? Yes. So we'll put it 10 at the, so we'll check each of the element actually. Okay. So and then put it where it's just proper position, because 10 is less than 50, 40, and 30. So for doing that, actually we need to shift these three guys, right? We're shifting these three guys. Then a room is empty here, we just put that number here. Now we have 20, right? So now we are checking, is 20 is less than 50? Yes. Is 20 is less than 40? Yes. Is 20 is less than 30? Yes. Is 20 is less than 10? No. Then we'll stop in this position. Clear? We have to make room, right? Because we found a proper position for this unshorted guy, right? So we have to shift these three guys to right, make a room for that unshorted guy, and now it will be shorted. Clear? Any questions so far for this insertion short, how it works? You understand clearly? So first one we saw selection short. Why we're calling selection short? Because maybe you can say each time we select a number that is the smallest one, right? And then we're swapping. So that's why, since we're select a number, the smallest number, maybe we're saying selection short. For this one insertion short, we take a number, insert it to its proper position. Maybe you can assume for that reason it's called insertion short. Okay, you can. So this is just my idea how I can remember like which sorting algorithm is working how. Maybe you can design your own, but maybe you can use this if you want. Clear? So any questions so far? Okay. So now we'll start bubble sort. Okay. So what's the main concept here? It's kind of different. It's kind of reverse, right? So here, so all the time we put the sorted list at first, then the unsorted list, right? But for this one, actually, our unsorted list will be on the left side and the sorted list will be on the right side here. So what we are doing here, the larger elements bubble to the right. Okay. So it's kind of, you know, that you are creating some bubble and the very like the largest element, largest bubble will go right like that. Okay. So that's what we're saying. Largest element move to the end of the unsorted list, make it sorted list, right? Sorted sublist grows by 1 for sure, and unsorted shrink by 1. What's the algorithm here? At first, in the unsorted sublist, we have the original list, right? In the sorted sublist, we have an empty list. Clear? So how the iteration work? So we are scanning forward from the beginning of the unsorted list. Each time now, rather than taking a single number, we are having a pair of numbers. Clear? Suppose A1 is the first element, A2 is the second element. We will just compare between them. Okay. Then again A2, A3 after comparing. Like if A2, okay, if this A1 is greater than A2, we'll swap. So that's what is written. If AI greater than AI plus 1, we'll swap between them. Okay. So we'll go each of the pairs. After swapping, we'll go for A2, A3. So just like that, in the unsorted list, we'll go pair by pair. Okay. So whenever we're doing like that, after a scan, the largest element has moved to the end of the unsorted list. We'll see how. And then you know that the unsorted sublist shrink by 1 and the sorted sublist increment by 1. So this is the way we are doing here. So you know that we have these numbers, right? So now what we're doing, so you know that this red bar now at the end of the list. Why? Because for each of the sorting, we put this red bar between sorted and unsorted list. So the idea is quite different here. We are not putting the sorted list at first, rather than we are putting unsorted list at first and then the sorted list. Clear? So in the first iteration, like I said, it will take a pair of numbers like 30 and 40, right? So is 30 greater than 40? No. So it will not do anything. Then it will come the next pair, that is A2 and A3, right? So is 40 greater than 50? No. Then it will do nothing. Come to the next pair, okay? Pair by pair, right? So now we have 50 and 10, right? So if 50 greater than 10, yes, swap. Okay, so 10 and 50, right? Then again come to the next number, right? We have now paired as a 4 and a 5, so 50 and 20. So is 50 greater than 20? Yes, swap, right? Clear? So you know that after the first iteration like this, we got 50 in its final position. Like I said in the previous slide, the largest element moved to the end of the unsorted list. So you know that our largest element is 50. By this way, it goes to the end of the unsorted list, right? Okay. Actually, by each iteration, we are getting the largest number at first. So this 50, we can put it in the sorted list now. Now we have these four numbers. Again, same thing. 30 greater than 40. No, do nothing. Then again, we have this 40 and 10. 40 greater than 10. Yes, swap. Clear. Then coming to the third position. Okay. 40 and 20. Okay, so you have to remember that this, like, you are going through each of the element of the list, right? So you are going at first number one, comparing 1 and 2, then going to the 2 position, comparing 2 and 3, going to the 3 position, comparing 3 and 4, and it's the updated list. You are like applying the algorithm on the updated list. That means that whenever you are doing swapping 40 and 10, you are not counting this for the next iteration. Like in this phase, you are not counting this list. You are counting the updated list. Clear? You are counting 40 and 20 now. So 40 greater than 20, yes, swap them. Okay, we got our second largest value actually. Clear? And this will be in the sorted portion now. Clear? So now, do you have any question how these things are working? Okay, so now we have in the unsorted list 3 numbers, right? At first, because this is our, so whatever the list we are getting at the very last phase of the iteration, of the last iteration, will start from there. Okay, whatever we have at the very last, we'll start from there. Clear? Okay, so now we have 30, 10 and 20. Again the same thing, 30 greater than 10, yes, swap. We have 30 and 20 now, 30 greater than 20, swap. Now we have this, right? So we got 30, 40 and 50 in our sorted list, right? And then we have this unsorted list, again same thing, 10 greater than 20, no, right? So it will do nothing. So there is a typo here actually. So it will be 10, 20, 30, 40, 50. Okay. This is a typo actually. So by this way, this bubble sort works. Here. So far we already know how selection sort work, how insertion sort work, how bubble sort work, right? So do you have any like preference, like which sorting algorithm do you like most so far? You can comment in the chat box. Or which of the criteria you should consider, like which one you should like or not.
You mean which one is easier?
Maybe the first question was like looking at this treater like sorting algorithm. Is there any particular choice like I like this sorting algorithm or not? It's just like, you know, it can be randomly like each person can choose different one. So Chima is saying bubble sort is the most simpler and easier. Maybe yes. So then my second question was that which things you should consider, right? But that question is not part of this course because it's not like the data structure and algorithm course or the analysis of data structure course, because we are not emphasis on the, you know, efficiency of our running time or code things, right? We just want to know how these things works in Java, nothing else. Clear, Inga?
Oh, do we need to know how to implement the code of sorting?
I don't think so, but the code is already given in your Nexus. I uploaded.
Yes, I mean like for exam, for instance.
I will let you know if you need to know like but for sure you have to know the basic idea like how this sorting algorithm works, right?
Yes,
So
yes,
if
like,
you already
but
know that, then you can also code it, right?
yes, but I still would like to know if it's possible.
Yeah, so for now it's better if you learn how things working, like not in theory, also in practical, because the codes are given. Okay, I will let you know if you don't need it.
Okay, thank you.
Okay, that will be better rather than saying you don't need it and then I have some question, right? Yeah, so it's easy, right? If you know the concept, you can do it, right? Okay, clear. So which one do you like most? Selection sort, insertion sort, or bubble sort?
I know bubble sort is
Bubble
the
sort.
easiest.
Okay, the bubble sort is the winner then so far. Anyway, so we have one more sort left, and that is quick sort. Okay, so Thomas is also liking the bubble sort. Okay, so 3 vote for bubble sort, so bubble sort is a winner. Now we are going to see the quick sort. Okay, so this is the different than the previous 3 sorting algorithm because we are saying this is recursive. Okay, we'll see. So what we are doing in this sorting algorithm, we are continuously subdivide a list into 2 sublists based on a pivot value. Okay, so how this pivot is chosen, depending upon that, there can be variations of this quick sort, but that's not our headache in this course. Okay, so for now in this course, let's choose the very first element of a sublist as pivot. Okay, so like we are saying, we will always choose the first element of a sublist as a pivot. Clear? Then what we are doing, we are creating 2 other sublists. Okay, and we'll organize those sublists as a way that whatever the pivot you choose on the left sublist, all the elements will be less than that. On the right sublist, all the elements will be greater than, or it can be equal also. Clear? So let us go to the scenario, like how these things is working. Suppose you have this list of n elements, y1 up to yn. Okay, so what we are doing here, we are just choosing a pivot value x. So you know that now these numbers, okay, all of the numbers, it should be less than x. all number here on the right sublist, it will be greater than or equal to x. Clear? And then now, can you understand like why we are saying recursive? Because the same thing you will apply also these two sublist. You have this sublist, you have this left sublist, you have this right sublist. You are applying the same algorithm in the left sublist also. Choose a pivot. Okay. Then place the pivot in the position where the left sided numbers will be less than that pivot number, and the right sided numbers, it will be greater than or equal to that number. Okay. Again, you have the right sublist. Apply the same algorithm, that is choose a pivot, and then on the left side it will be smaller, on the right side it will be greater than or equal to. So that's the kind of algorithm we are going to follow. So this is the algorithm. Okay, so now at the very first line we can see if list of length less than equal to 1, then return. Okay, next, choose a pivot value x, rearrange the element of list. What I already told you, left sublist will be less than x, right sublist will be greater than or equal to x. Now, like I said, this is a recursive function, right? So we are calling this function with this list L. Again, we are calling this function, recursive function, with this list R. Okay. So now who can say which one is the base case here? Anyone can suggest me which one is the base case here, where we are stop the recursion part? Anyone? So looking at these lines, the answer is here actually in this slide. Okay, the base case to stop iteration when we are going to finish the recursive part, you know. No one can answer that. What about number 1? If list of length less than equal to 1, then return, right? So that's actually your terminating point, right? Is it clear? So is recursion is clear, then it should be clear that this should be the base case, right? Any question? Okay, we'll go for the example then. Okay, so we have a list. Okay, for this example, the list is quite bigger because you know that we are kind of dividing into left and right one, so we need larger numbers. Okay, so like I said, or the algorithm said, choose the pivot as the very first element of the list, or of the unsorted list, right? Clear? So here you choose 6 as pivot value, right? And then the number 3, rearrange the elements of list using like the pivot value, put the position in a way that the left sublist will be less than the x and right sublist will be greater than or equal to x, right? So that's the way we can do, right? So we will go one number by one number, right? Maybe we just create 2 empty other lists, right? We'll say like 6, 5, it is less than 6, yes, throw it to the left sublist, right? 9, is it less than 6? No. So you know that in the else part you will just throw it to the right hand side. Okay, just like that. Clear? So just like that, you know that all the numbers here are less than 6. All the numbers here are greater than 6, right? So now what we're doing here, we are so this 6 will be the, like, this 6 is just like already part of the sorted list, because it's just like we said, if the list length less than equal to 1, so this is less than equal to 1, or this is equal to 1. So that's why we're not bothering with that one, rather than whatever the you created the left sublist, whatever you created the right sublist, you know that you will call the same algorithm again, right? Again, it will choose the first number as pivot, right? And it will just compare each of the number. If it is greater than equal to that pivot value, it will throw it to the, it will put it in the right sublist. If it is less than the number or the, like the pivot value, then it will put in the left sublist. Okay, so that's why 5 and 4 goes to the right sublist, and 201 is going to the left sublist. Okay, so here as well, if you look at the right side, you know that these things can work in parallel, right? Okay, so now we have the pivot as the very first of the sublist, right? Whatever the numbers are less, we put it here, and greater than equal to number, we put it here, right? Okay, so now 3 we got fixed, right? And then we are calling this one again, calling this one again, right? So again, the very first one will work as pivot value, right? And then we don't have any right sublist now, because 0 and 1, they are smaller than 2, right? Clear? Okay, so now what about the right sublist? Select the first one as the pivot value. Okay, again, no right sublist because 4 is less than the 5, right? Clear? Then what we're doing here, we have this left one, we don't have any right one because they are all 1, like the length is 1, right? So this one again will apply our algorithm, right? So 1 will be the pivot, you know that we put it as a pivot, and 0 is less than 1, put it here. We're done, right? On this side, we're done. So we got 0, 1, 2, then 3, then 4, and then 5. Then we have 6, right? And then in this side, we already explained up to this, right? And then we know that this is where the algorithm will apply. Also, this is where the algorithm will apply. Again, choose 9 as a pivot value. Again, 7 and 8 all are less than 9. That's why we put it here. Okay. And then for 12 and 11, choose the first element as pivot. 11 is less than 12. We put it here. Right. Now we only have these 7 and 8 sublist to apply our algorithm, because it's greater than, the length is greater than 1. Right. So again, choose the first one as pivot. The 7 is pivot now. Now 8 is greater than 7, we put it here. So this way, actually you got the other numbers like 6, then 7, 8, 9, 10, 11, 12. Okay. Is it clear, everyone, how this quick sort algorithm is working? Any questions so far for this quick sort? Now, which one do you like among these 4 sorting algorithm? Or is still your choice is still the bubble sort, or it's updated to quick sort? So in this way, like what we are doing, this is actually we are calling divide and conquer approach. We're dividing our main sublist, right? Okay, and at last we are conquering those. Okay, you don't need it. You can just, like I will not ask this one in the exam for sure. It's just like a concept. You will learn it later. Clear? So any questions so far? Okay, so now all of these shorting things are already uploaded in your Nexus. Okay, there are some examples also given. Okay, and there are some note given here like that. If you look at the dark.java file, it implements the interface called comparable, and it call that compare2 method to short those. Clear? So now we are done with the shorting part. Okay, so now how we can do searching? That's the second part of our lecture, right? Okay, so there can be two scenarios. One can be an unordered list, another can be ordered list, right? Clear? So what do you mean by ordered list? Actually, it's shorted, right? Clear? So now if you are searching in unordered list, okay, it's kind of a brute force method. That means that you have to go each of the number. There is no way you can like you can opt out, or you are not considering a number on the list. You cannot do that. You have to go for each of the number one by one to search, because it's unordered list, right? So that is how the algorithm works. Okay, you have a list, unordered list, and you have a number to search. X is the number you are searching for. Okay, so at the very first, your eye point to the start of the list, right? And then you are go up to the end of the list, right? If the list index I equal X, you are just return, right? That you are found at position I, that number. Otherwise, you are incrementing I to reference the next element of the list, right? So this is the while loop. By this, it will just search whether that number is inside that list or not. Okay, clear? So what can be the best case scenario here? You can get the number at the very first iteration, like the number is actually 0 index, right? That's your best case scenario. Whatever the worst case scenario here, the number can be, the number is not there maybe, or if it is there, is the very end of the list. You have to iterate each of the number and then you found it. That's the worst case scenario here, right? Clear? So now, what about the searching in ordered list? Okay, any questions so far? Okay, so for the ordered list, okay, we will go for two search algorithm. One can be sequential search and another can be binary search. Okay, actually we already discussed it in the class about the binary search, if you can remember. Clear? So what about if you have a sequential, like the ordered list, right? And we're doing it a sequential search. Okay, so like the previous, also for I, we are pointing the first element of the list, right? And we have to go at the end of the list also, right? Okay, but here what we can do, we can follow a trick here, right? So when we are saying that this is like this is shorted, right? So we can check this whether the list I, the very first element, if it is greater than the number we are searching for, we can say that it's not there, right? Suppose your numbers in the shorted list is like 30, 40, 50, 60. Then you are searching for 10, right? So you already know that the very first element, that is 30, greater than 10, right, you can just return not found, right? So this is the advantage of the shorted list, right? Okay. Then there can be another scenario that list I can be equal x, right? Then you will return found at position I. Then you are going to increment your I, right? And then you will go for the rest of the numbers like that. Is it clear? Any questions so far? Okay, so now we'll go for the shorted list, but how we can apply binary search here, right? So if you can remember in the class, we already discussed about this. Okay, so in the list L is empty, right? So it can be possible, then just return not found, right? Then we are kind of determining which one is the midpoint, right? Kind of a pivot, right? We already know in the binary search, all of the element on the left side that is smaller, on the right side is bigger, right? Okay. So that's why we're checking whether the number we are searching for, if it is less than the midpoint value, we'll just call the binary search left sublist and x, right? If it is greater than, then we'll call binary search right sublist x, right? But also there can be scenario that pivot is what we are searching for, like x is the midpoint value, then we will just return found at position midpoint or that position. Is it clear? So this algorithm, we just see it, is an example of what? Can anyone tell me? What kind of example is this? Can you refer to any other topic of our course? This is also what? Recursion, right? Because you know that this is our first, like the function name. We are again calling the same function name, right? Just like what we call in quick short, just like that, right? Is it clear? So now this is our end of topics. Okay, so this is actually our very last slide here. So in the next class, maybe I'll go for just describing a bit of your assignment number 4. Okay, and then maybe we'll go for, maybe we can go for some examples in shorting or in recursion. Okay, and we have 2 more classes left, and the very last class we can go for the midterm, the final exam review here. So do you guys have any question regarding anything? So I have office hour up to 1:30 today. If you need or like for any concern for anything, you can just email me. We can meet in Zoom if you want. Okay. Have you finalized how the final exam will look like? No, still not. It's not like it's just not just only me. Me and Janet will finalize that one. So hopefully we'll give some idea next week for sure. Next Thursday for sure. Okay, not before that. Clear? Any other question?
Will the exam be given to us for the whole day or several hours? Like you will post it, let's say at
Still
6,
it's
and
not
you won't
decided.
check it.
If it is like the take-home exam, you know that maybe one day or several hours. So still it's not decided. So for now, I cannot say anything like what it will be because we haven't finalized yet.
Okay, okay. Thank you.
So any question for today's topic? Is there anything you are not clear with? Okay, whoever couldn't join, I'll upload this recorded video also in your Nexus. So if you don't have any other question, we can end today's class. So I will see you guys on Monday then. Stay safe, everyone.